Good morning all. My name is B. Santhosh Kumar. My subject is image processing. Today I am discussing about linear and non-linear operations. So before going to this topic, we are discussing digital image fundamentals. So what are the digital image fundamentals? Elements of visual perception, image sensing and acquisition, sampling and quantization, relationship between pixels, spatial and gray level resolution, linear and non-linear operations. So these are under digital image fundamentals. So everything we are the important role in image processing. So elements of visual perception. So what are the elements? So what are the elements we need for the creating a digital image? And what is the image sensing and acquisition? So what are the hardware and software requirements are there for image? And sampling and quantization means analog image is converting to the digital image, like, and the relationship between pixels. So how many pixels are there? What is the relation between the pixels? And the spatial and gray level resolution. So spatial and gray level means every image we have some intensity values are there. So we are forming one intensity values for the every pixel. So that is a spatial and gray level resolution. Next one is a linear and non-linear operations. So what are the linear and what are the non-linear operations we will discuss today. So what is linear and non-linear image? A linear data that your camera records will look every dark and low in contrast as raw data. A non-linear curve needs to be applied to make it and look like a normal image that we expect to see. If your JPEG image is there in the camera, the processor in the camera applies that non-linear curve. So before going to that one, what is the linear and what is the non-linear? So what is a linear and non-linear? A linear data in your camera records will look very dark and low in contrast of a raw data. Suppose I have an image. That is in the form of white or black. Okay, so if it is in the form of black or white, that is a linear. So a linear data in your camera records will look very dark and low in contrast as a raw data. That is a linear. And a non-linear curve needs to be applied to it, make it look like a normal image that we expect to see. So suppose my image is a black or white. So suppose black is very high or white is very high. So contrast is very high. So I have to reduce. So I have to identifying image. Non-identifying image is converting to the identifying image. So I have to reduce the contrast. So after reducing the contrast, what is the image? That is a non-linear. Linear means originality of the image. What is the look? Original image from the camera. That is a linear. After we are reducing some noises, after we are giving some settings of contrast adjustments, or increasing or decreasing the contrast, or increasing or decreasing the black and white color. So those are the non-linear curves. Means we are adjusting the original image. What are the adjusting of original image? What we are adjusting the linear. That is a non-linear curve. And suppose I have the JPG image in the camera. The processor in the camera applies the non-linear curve. So when the JPG image is there in the camera, that our processor in the camera applies that non-linear curve. So linear data that your camera records will look very dark and very contrast is high. Suppose the image is there, that image has a black and white is there. So when the contrast is raw data, it is a very dark and low in contrast. A non-linear curve needs to be applied in make it look like a normal image that we expected to see. Suppose my original image has a black is very high and white is very low, or white is very high, black is very low. Example. So it is looking like not a good image. Why? Because the contrast is not adjusted. Okay, that is not, the contrast is normal, not in normal. Okay, so the contrast is very high. So I have to adjust. So how much means? Suppose I am adjusting black and white levels. Black and white levels are adjusted. adjusted from linear image. Okay, so what are the black and white colors are we are adjusted from the linear, that is a non-linear. So camera records will very dark and low contrast as raw data. A non-linear curve needs to be applied to it, make it look like a normal image, and that we expect to see. Okay, so what is the original image? That what is the original image? Maybe the contrast is high or contrast is low, so that is called linear. So what are the adjustments we needed from the linear? That adjustments I was done. That is a non-linear. Okay, so the human sense, however, is not non-linear. Okay, they are closer to logarithmic. So the eye expects to see something more closely approximating a log curve, which is what non-linear means basically. So okay, human senses. Suppose human visible image, that is a non-linear. Why? Because some linear means not adjustable image. Okay, maybe the contrast high, contrast is low, or brightness is high, or black is high, or white is some low. So we can't see, even human will not see. Why? Because it will be affected to our eye. So we are adjusting something from the original image, that is a non-linear. So here they are telling human sense, however it is a non-linear. When the human is using that image is a not a linear, that means non-linear, and they are closer to logarithmic. Okay, we are adjusting something from the non-linear, that is from the linear, that is a logarithmic, and the eye expect to see something more closely approximating a log curve. So the eye is closely expecting something. So that is linear will affect the eye. Right. So for this purpose, I am going for the non-linear. We are going for the non-linear. So linear filtering is a filtering method in which the value of the output pixel is linear combination of the neighboring input pixels, and it can be done with convolution. For examples, mean or average filters or Gaussian filter. A nonlinear filtering is one that cannot be done with convolution or Fourier multiplication. Suppose in the previous we discussed, suppose I am going for the linear, nonlinear. So linear and nonlinear images are there, but here I am discussing linear filter and nonlinear filter. So what is a linear and nonlinear image, and what are the linear filters and nonlinear filters? So linear filtering is a filtering method in which the value of the output pixel is in linear combination of the neighboring input pixel. So suppose I'm going for the linear filtering, means maybe the original image from the camera, what the camera is captured the original image, that is a linear. Okay, filtering means we are adjusting, so removing the noise or adjusting the brightness or something. So it is a filtering method in which the value of the output pixel is a linear combination of the neighboring input pixel. Okay, so what is the applying the linear filtering to the linear image? The output is a combination of the linear neighboring input pixel, and it can be done with the convolution. For example, mean filtering or average filtering or Gaussian filtering. A non-linear filtering is one that cannot be done with a convolution or Fourier multiplication. So when I am doing mean average filtering or Gaussian filtering, those are I'm calling as a linear filtering. But in a non-linear filtering, it is done on the, it cannot be done with convolution or Fourier transform. Convolution or Fourier multiplication is a not a non-linear filtering, is one that cannot be done. Okay, it is not a non-linear. Not a non-linear. Okay, so linear filtering is a filtering method in which the value of the output pixel is linear combination of the neighboring input pixel, and it can be done with convolution. So the mean or average filtering or Gaussian filtering in nonlinear filtering is one that cannot be done with convolution or Fourier multiplication. And a non-linear filtering have quite a different behavior compared to a linear filter. Okay, they have some variations are there in the linear and non-linear. So what are the quite differences, what are the quite a different behavior with the non-linear and non-linear? Suppose for non-linear filter, the filter output or response of the filter does not obey the principles outlined earlier, and particularly scaling and shifting invariance. So when I'm going for the non-linear filtering, the filter output or response of the filter does not obey the principles or outlined earlier, particularly scaling and shifting invariance. Suppose the scaling and shifting invariance are there, those are, we have to follow the non-linear filtering rules. Non-linear filtering. So scaling and shifting invariance are the non-linear filterings that we are not obey the principles of outlined earlier, and moreover a non-linear filter can produce results that vary in a non-initiative manner. So a non-linear filter, it can be produce the results that vary in a non-initiative manner. So what are the partial differences, quite differences of linear and non-linear? Means suppose in a nonlinear filter, the filter output or response of the filter does not obey the principles or outlined earlier, and particularly scaling and shifting invariance. Or moreover, a nonlinear filter can produce results that vary in non-initiative manner. Okay, we have some slight changes from the original image. That is a nonlinear filtering. And if the JPEG image in the camera that will be captured, so the camera is capturing the image that is in the form of JPEG, and the processor in the camera applies that nonlinear curve. Okay, when the image is in the form of JPEG format. Okay, so this JPEG is in the camera, the processor in the camera applies nonlinear curve. So it is a nonlinear curve, or it is like this. So when the image in the form of JPEG, that is I'm calling as a nonlinear, that is in the form of nonlinear curve. So the images in the astronomical image processing program, you will normally be working with the linear data. When the stack output is saved, then we have to apply the nonlinear curve to it yourself during image processing. So when this was in a nonlinear form, otherwise linear curve also converting to nonlinear. Curve. So when the image processing program, it will be working with linear data, and the output is saved with nonlinear curve also, and it gives the greater control over how the data is stretched. It is increasing the brightness or contrast of the faint stuff astrological image we have to show. Okay, suppose this image brightness adjustment. Okay, when the brightness is there, it is the original brightness is a linear. Okay, when we are doing the adjustment for the brightness, I am calling as it is a non-linear. Okay, so when we are adjusting or stretching the increasing of the brightness and contrast of the astronomical image that you have to shot. So when I'm increasing the brightness, here I'm increasing the brightness and contrast. So the original image, what is the brightness? I'm increasing the brightness and contrast. So I'm increasing the brightness and contrast. So what is the original brightness and contrast? That is a linear. So how we are adjusting the brightness and contrast? That is a non-linear. Okay, we are adjusting that. That is called adjusting. That is a non-linear. So a raw file format or linear, but when you open a raw file in a daytime image processing program like Canon's Digital Photo Professional or Photoshop, it will automatically apply a non-linear curve. So already I have some original image with a linear curve is there, but this raw file format in a linear, but when you open a raw file in a daytime, the image processing program like Canon's Digital Photo Professional or Photoshop, it will be automatically applied to a non-linear curve. So this image is a digital image. Okay, this digital image I am converting to the print or color print. Okay, so it is calling as a non-linear image. Non-linear image. So sensors are capturing the image, that is a digital image. That digital image is converting to the color print. It is a non-linear operation. So a raw format of a linear, but when you open a raw file in a daytime image process program, Canon's Digital Photo Professional. Suppose I am taking Digital Photo Professional or Photoshop, it will be automatically apply a non-linear curve. When I am going to the Photoshop or anything, or we are editing something from the original image, from the linear image, that is a non-linear curve. So what are the linear operations? Suppose any image operator H is said to be a linear operator of two images F and G and two scalars A and B. Suppose I am taking two functions. Suppose image has a two linear functions. Any image has a H is to be linear. Okay. So any two images F and G and any two scalars A and B. So any two images, that is a F and G. A and B are the scalars. Okay. So F and G are the two images and A and B are the scalars. H is a linear. Here I am taking linear. Sometimes I will take non-linear also. But what is the equation? Capital H of AF plus BG is equal to A into H of F plus B into H of G. So H is a linear function and A and B are the scalars, and one scalar is multiplication with one image, another scalar is multiplied with another image. Okay. So first image with first scalar, second image with second scalar. Okay. So any operator that does not satisfy the above condition is defined as a non-linear. If it is linear, it is a linear. If not satisfied this condition, it is called non-linear. So it is called non-linear. So any operator is not satisfied the above condition is called non-linear. So what is a linear image operation? Means capital H of AF plus BG is equal to A into H of F plus B into H of G. It is a linear function. So F and G are the two images and A comma B are the scalars and H is a linear operation. So HVN operator whose input and outputs are the image, and H is said to be a linear operator, and two images are F and G and the two scalars are A and B. That is a H of AF plus BG equal to A into H of F plus B into H of G. So if it is, this condition is fails, it is called the nonlinear. So what is the exact equation? Linear and nonlinear operations. H is said to be a linear. If I am taking the linear, it is an equation. So it is not satisfied means nonlinear. So nonlinear filtering or nonlinear filter is a spatial nonlinear operator that produces the output image array g of x comma y from the input image f of x comma y. So already we know that two equations. input image is a f of x comma y. Input image g of x comma y is a output image. So a nonlinear image that produces the output image is a g of x comma y, and the input array is a f of x comma y in the following way. G of x naught comma y naught is the obtained using a nonlinear function applied to the value those pixels of the input image f of x comma y and lie within a neighboring of a pixel x naught comma y naught. When I am using here x naught comma y naught, here g of x comma, here I am taking g of x naught comma y naught. So what is g of x comma y and what is g of x naught comma y naught? If it is a non-linear, then I am calling as a x naught comma y naught. If it is a linear, I am taking as a g of x comma y. So g of x naught comma y naught is obtained as a non-linear function and it is applied to the values and those pixels of the input image is a f of x comma y. So this g of x naught comma y naught is a non-linear output. It is a non-linear output. But what is the input? What is the input means f of x comma y is the input for this function, that is a g of x comma y. It is a linear. G of x naught comma y naught is a non-linear and it is a neighboring of a pixel with x naught comma y naught. So what is the output? G of x comma y equal to tau of capital F of x comma y. Tau is a combination, linear or non-linear function with f of x comma y. So f of x comma y is a matrix of the neighboring of a pixel x comma y. Tau is a operator. So what is the operation you are using, linear or non-linear, whatever may be. So g of x comma y output equal to the operator, input operator with input function f of x comma y. It is a non-linear filtering, and non-linear filter can be divided into two groups. What are the two groups are there? So here tau takes in account the position of the individual values of f of x comma y. Tau does not take into account the position of the individual values of f of x comma y, and the value of the matrix are considered as a set. So the tau takes into the account of positions of the individual values. Here I am taking f of x comma y. It is a input, but these are the individual values. So the account of positions of the individual values of capital F of x comma y and does not take into account the positions of the individual values in capital F of x comma y, and the values in the matrix are considered as to be set. So there are two sets are there, small f of x comma y, capital F of x comma y. So when I am taking the operator with input, okay, that is a non-linear types. And another important classification of an image processing method is that let h be a general operator. Capital H of f of x comma y equal to g of x comma y. So it is the output and f of x comma y is the input. So what is the h? H is said to be a linear operator. So it is a linear. So capital H of f of x comma y equal to g of x comma y. So the classification of the image processing method is in the capital H to be a general operator. So capital H is a general operator. It is multiplying with input image. So the input image with the linear operator is the output of g of x comma y. Suppose H equal to non-linear. Example I am taking non-linear. What will happen? G of x naught comma y naught. So capital H of ai into fi of x comma y plus aj into fj into x comma y is equal to ai into h of fi of x comma y plus aj into h of fj of x comma y is equal to ai into gi of x comma y plus aj into gj of x comma y. Okay, we are multiplied each other with input and output. Okay, that is a linear operator. Next, non-linear filter have a quite a different behavior compared to a linear filter. For non-linear filters, the output response of the filter does not obey the principles outlined. Moreover, a non-linear filter can reduce the results that vary into the non-linear manner. So, the in linear and non-linear are quite different. So, the several principles define a linear system the first two are the basic definitions of linearity. So what are the linear function and what is a non-linear function? If a system is defined have an input as x of n equal to a into x of n1 plus b into x of n2, then the linear response is y of n. That is output y of n equal to a into y of n1 plus b into y of n2. So a and b are the two scalar functions, n1 and n2 are the two different inputs are there. So what is x of n here? It is a input value and it is a output. Okay, so the system is defined has to be a input is x of n equal to a into x of n1 plus b into x of n2, and the non-linear system is y of n equal to a into y of n1 plus b into y of n2. So the superposition property of a fundamental to linear system design, the second priority of the shift invariances is that one. And what is a y of n? The output is the response of a linear shift invariant system with input x of n, and output is a y of n minus n naught, and the response of the system with input of x of n minus n naught. Okay, it is the input response and it is the output response. So in addition, two extra conditions are implemented in casual and stable system. So what are that means? Casual and stable systems are in the linear and non-linear. So what is a casual and a stable system? So the casual condition is needed when considering system in which future values are known as. For example, in a video streaming. Okay, when the image I'm taking here and I'm taking as a not a image, I'm taking as a video streaming. So when I'm operating a video streaming, it is needed to be considering the system with future values. Okay, it is known known as a casual condition. If it is possible to consider a system that is not in a casual, okay, not in a casual. Here I'm taking casual condition. Here I'm taking not in casual condition. It is looking as a captured images with samples before and after the target location. For example, in a buffered version of an image frame. Okay, here I'm taking video streaming. It is a casual system. When I'm not, it is going for the non-casual. So what is a non-casual system means? So when I'm buffering the version of the image frame, okay, when the images or video is buffering, okay, that is a not a casual condition. Okay. Next, stability. So here casuality is a casual and non-casual. Here stable and non-stable. Okay. So what is the stable is imposed to keep a filter output from exceeding a finite limit given an input that also does not exceed a finite limit. Okay. So stability is imposed in the filter output from the exceeding a finite limit is given as the input of the also designed with exceeding a finite limit. Okay, and this is also called bounded input, bounded output, BIBO condition. Okay, so when I am applying the BIBO condition means when it is in a stability condition, it is in the form of stability. So the stability is imposed to keep a filter output from exceeding the finite limit. It is given in the input that also does not exceed it in a finite limit, and it is also called bounded input and bounded output conditions. Most cases, the evaluator of the spatial frequency domain, it accomplishes that the convolution theorem is used to provide the necessary tools to evaluate frequency domain information. If x of n and h of n are two sequences and their convolution is defined as shown in equation. Suppose the output y of n is equal to summation k equal to minus infinity to infinity x of k. Okay, that is the input with operator. What is the operator here? Linear or non-linear? Okay, so output with operator, that is a linear or non-linear operator with input, that is a x of k. So when the system is evaluated in the spatial frequency domain, it is accomplished in the convolution theorem is used to providing the necessary tools to evaluate frequency domain information. Okay, so the spatial frequency is converting to the frequency domain information when the image is in the form of x of n and h of n are the two sequences and their convolution defined as a equation y of n equal to summation k equal to minus infinity to infinity input function x of k and operator h of n minus k. So the corresponding frequency response in the equation 2. So what is the Fourier transform? I am applied the Fourier transform to the above equation. Okay, capital Y. Here I am taking small y. Okay, when applying the Fourier transform of this one, that is called equation 2. Okay, so I am applying the Fourier transform, that is capital Y of e power minus j omega is equal to capital X of e power minus iw into capital H of e power minus iw. Okay, so the Fourier transform of the input above equation 1, for equation 1 applied Fourier transform, that is in equation 2. So the Fourier transform of the equation 1 is in equation 2, capital Y of e power minus j omega, it is a output function, and with capital X input function, and with operating function. So in the equation 2, e power minus iw is the frequency domain response, and w is the frequency variable, that is from minus p to plus p. Okay, so the fundamental relationship describes the response of a filter in terms of frequency, low pass and high pass and band pass and so on. So depending on the nature of the filter, kernel H of n, a wide variety of responses can be realized for any image. So here this function is for linear or non-linear, linear filtering or non-linear filtering. But the fundamental relationship describes the response of a filter in terms of frequency, low pass, high pass, band pass and so on. Depending on the nature of the filter, that is in the function of H of n, it is a wide variety of responses can be realized for any image data set. So a typical low pass filter with 25 taps, okay, that is from H of 0 to 24, okay, 25 are there. So when I'm going for the low pass filtering is to preserve a low frequency information and reduce to eliminate high frequency information in an image. Okay, so here I'm using low pass filters are there, high pass are there, and band pass are there. But here I'm using, for example, low pass filter is to preserve the low frequency information, low pass filter for low frequency information, and to eliminate high frequency information in an image. When I'm using the low pass filtering, it will be eliminating high pass filtering. It will accept only low pass filter or low pass frequencies. Okay, it is blur images, keep smooth areas of an image interact. When I'm using low pass filter, what is the advantages? Okay, the blurring edges keep smooth. Okay, blurring of the images, sides of the images blurrings are there, it is converting to the keep smooth, and it is in a similar manner. High pass filter preserves edges and other high frequency information, but filter low frequency regions of an image. When I'm using high pass filter, means it is accepting high pass frequencies and it eliminates low frequencies. And what is the advantage with high pass filtering? Means it preserves edges and other high frequency information, but filter low frequency regions of the image. Okay, so in the next figure, where low pass filter maintains low frequency and eliminates the high frequencies. Okay, low pass means it is low frequencies. Next, high frequencies means it is eliminated. Okay, low pass will accept low frequencies and it will stops high frequencies. Okay, it is one graphical image of normalized frequency with filter response. Okay, it is a x-axis, it is a y-axis. Okay, from the x-axis, what I am taking? X-axis I am taking as a normalized frequencies, 0 to 1 frequency, 1 Hz. Here I am taking minus 120 to 20 filter response. Okay, filtering from minus 120 to 20. So frequencies from 0 to 1 Hz. Okay, it is a low pass filtering with 0 to 24 range. Okay, when I'm going for the non-linear filtering, non-linear filters have a quite different behavior compared to linear filtering. For nonlinear filter, the filter output of the response filter does not obey the principles outlined earlier, particularly scaling and shifting invariance. Okay, when I going for the nonlinear functioning, okay, it is quite different from the linear functioning, and scaling and shift invariance are the nonlinear functioning, and nonlinear filter can produce results that vary in the nonlinear curve. And what is the simplest nonlinear filter to consider is the median or rank order filtering. And a filter support range with n odd numbers. The value is to making easy to select the output. It is a nonlinear functioning. Okay. So suppose I'm taking a filter is based on 5 values, that is x0 to x4. Total 5 values I'm taking. The values are ordered from smallest to largest. The value position is 2, selected is the output. So in case of low frequencies, all the values are then the same or close to it. Okay, when I'm going for the low frequencies, all values are same. Okay, so the value is selected will be the organization value plus or minus some small error. So in case of high frequencies such as edges, the value of the side of the edge will be low and the values of the other side will be high. Already we discussed in that low frequencies. So low pass filter means using for edges. Okay, so here high frequencies are using for the edges of n, sides of edges will be low and values of the side will be high. Okay, so this is for edges and smoothing operations. So it is a nonlinear functioning. So when your ordering is done, the low values will still be low position and the high values will be still in the high position. A selection of the middle value either be on the low side or in the high side, but not in the middle. It would be the case using a nonlinear or linear low pass filtering. Okay, so the median filter, sometimes called an edge perceptive filter, due to the property it is useful to removing outliers such as impulse noise. Okay, you can see first, once the ordering is done, the low values will still be in the low position. Okay, low values will be in the low positions always, and high values are in the high position. But what is the middle value? Either in the low side or in the high side, but in the middle side, the case using linear low pass. When I'm using the middle values, that is in the linear low pass filters. And the median filter is sometimes called an edge perceptive due to property. It is useful in removing outliers such as impulse noise. And selecting the right filter. Which filter is better for selecting? The both filter types have their place in the image processing functions. A typical pipeline real-time image processing, it is not uncommon. Have dozens of both types are included in form, shape and detection and manipulating image formation. Moreover, each filter type can be parameterized, work on the way under the certain circumstances and another way under a different set of circumstances using adaptive filter rule generation. So, which type of filter is better? What is the right filter? Okay, some filters are using for linear and some filters are using for non-linear. But which one is better for the right selection of the filter? Okay, and the filtering image data is a standard process used in almost all image processing systems. The goals vary from noise removal to feature abstraction. Linear and nonlinear filters have the two most utilized forms of filter construction, knowing that the filter selection depends on the goals of the nature. Okay, and a large amount of noise but the magnitude is low, linear low pass filter is made safe. And consequently, if an image contains a low amount of noise but with a relatively high magnitude, then a medium filter may be more appropriate. In case the filter process changes the overall frequency content to the image. Okay, so if I'm taking an image, it contains a low amount of noise. Okay, low noise. it contains low amount of noise, but with relatively high magnitude, then a median filter may be more appropriate. So when I'm taking as a low noise means it is better or not better image. For high noise, it is not somewhat better. Okay, so in an image contains a low amount of noise but with a relatively high magnitude, then a median filter may be more appropriate. When in the ether case, the filter process changes the overall frequency content of the image. Okay, it is a linear and non-linear operations. So in the image fundamentals, we discussed linear and non-linear operations. So here we discussed what is a linear and non-linear image. Okay, so linear means it is looking like a very dark and very low contrast raw data, and the non-linear need to be applied. It make it look like a normal image, and we expect to see. Suppose I am taking the JP image. Okay, it is in the camera. The processor in the camera applies the non-linear curve. Why? Because the maybe the variations, the noise will be changed, or the brightness or contrast may be changed from the original image. That is a non-linear image. So what is a linear and non-linear? Suppose the linear data, the camera will be record. It is a very dark and low contrast, but in the non-linear curve, it may be applied to look like a normal image. Okay. Okay. What are the changes are there from the original linear image? I'm calling as a non-linear curve. Human sense eye is a non-linear. Why? Because sometimes the eye will not, the contrast is high or low, the eye will can't see that original image. Okay, we have to slightly changes the modifications of the original image. That is a non-linear image. Okay, so the linear filtering method. What is a filtering method? Means reducing the noise or sharpening edges. Okay, those are the filterings are there. So how many types of filtering means? Linear filtering, non-linear filtering. So what is a linear filtering? It is a linear filtering with the value of the output pixel is linear combination of the neighboring of the input pixel. Okay, input and output I am taking as a neighboring pixels. Okay, that is a linear, and it can be done with the mean average filter and Gaussian filter. A non-linear filter cannot be done with convolution or Fourier multiplication. Okay, when I am taking one equation, okay, suppose a linear operation, that is capital H of AF plus BG equal to A into H of F plus B into H of G. So it is a linear operation. So what is means F and G are the two scalars, A and B are the two scalars, F and G are the two images, and H is said to be operator. That is a linear operator. So if this equation is satisfied, then I am calling as a linear. If this equation is not satisfied, then it is a non-linear operation. So it is a linear operation and it is a non-linear. Non-linear means I am taking the output is f of g of x naught comma y naught. It is a non-linear. Suppose I am taking g of x comma y. It is a linear. So h of f of x comma y equal to g of x comma y. It is a output operation, the output function with a linearity. F of x comma y is an input linear function. H is a linear operation. Okay, if I am taking non-linear means I am taking x naught comma y naught. So the non-linear functions are slightly different from linear functions. Okay, the several principles are there for the linear operation and non-linear operations. Okay, so these are the slightly changes when the two imposed functions are there first for the linear and non-linear. That is a casual and stable. So casuals are two types: casual, non-casual, stable and unstable. Okay, casual means video streaming. Okay, if there is any buffering in the video streaming, that is a non-casual. Okay, and what is a stable system? Okay, when I'm using the Fourier transform or using the filtering of that input or output images, I'm taking as a stability of the function. So that is also called bounded input and bounded output, Bibo condition. So these are the functions of input and outputs. Linear, it is a linear output operation. Non-linear. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.